Yeah.
Okay.
Good.
Okay, bit of a rocky start. So we've got 10 folks online. I guess 9 if you don't include me. I'll get started. I guess this will be fairly informal. But good afternoon, everybody. My name is Janette Meyrick. I'm an evaluation officer with the Canadian Construction Materials Centre at the National Research Council, and I'm also a lead on the Canadian Construction Materials Centre's Climate Resilient Product Assessment Pilot. And that is work that is undergoing under the NRC's Climate Resilient Built Environment Initiative. And I'm going to unpack some of these terms and names shortly. I was invited here today to speak about extreme wind events and the impact that they have on housing, how to address this through codes, and present some resources that are publicly available. But I think this is also a good opportunity to broaden the scope a little and speak to some of the other work that is underway at the NRC to address climate change related extreme weather events. So including things such as wildfire, flooding, extreme heat, and hail. So see if I can get my mouse to work here. Okay, good. Technical difficulties continue. I'm just going to start with a brief overview of the NRC's climate resiliency work as it pertains to Part 9 housing. I'll talk a little bit about upcoming adaptation and mitigation measures planned for the NBC 2025 and 2030 codes. Then I'm going to review some of the climate hazards that we're currently focusing on, and then finally go over some related tools and resources that can help with the decision making and design and rebuild process for buildings. So I'll start with some of the background on climate resilient initiatives at the NRC. Still having troubles with next slide. There we go. So the NRC has been working on climate resilient, climate change adaptation and resilience since 2016. And this has been through an ongoing partnership with Housing, Infrastructure and Communities Canada. So the first phase of this work was the climate resilient buildings and core public infrastructure work. So that ran from 2016 through to 2021. The second and current phase of the work began in 2021, and it is winding down to wrap up in 2026 March. In 2023, we received additional funding under the Government of Canada's Adaptation Action Plan, and this allowed us to extend our work and add a resilient residential retrofit research theme and climate resilient assessment pilot under the Canadian Construction Materials Centre. I'm tripping over all of these long names because I usually use acronyms, so I will try not to use acronyms, and I will continue to trip over all these big names. But essentially, the current initiative that we are working on has over 80 active projects. It's led by NRC researchers along with a network of partners from industry, academia, and other government departments. You can check out some of the major results and publications by clicking on the UR code at the top of your screen if you're so inclined. Diving a little bit deeper into our current work, some of the broader research topics underway include working with the Standards Council of Canada to support the development of a standard based on the National Guide for Wildland Urban Interface Fires. And we're also undertaking new research on wildfire smoke. There's work on nature-based solutions for flooding, erosion, and urban heat island mitigation. We're undertaking new research on extreme winds and tornadoes to develop new design loads for resilient buildings. There's additional work going on with for guidance for northern and remote communities, and we're developing guidance documents for the design of flood-resistant buildings. And this will be the third of a series of publications that looks at flood load combinations. So diving in again just a little bit deeper, as I mentioned earlier, additional funding from the Government of Canada's Adaptation Action Plan enabled the development of a new research theme called the Resilient Residential Retrofits. We call it R-Cubed internally because it's a long name and we like acronyms. So I may refer to it as R-Cubed. This project aims to support climate resilience for residential buildings through retrofits, as you might predict. And there's also a new pilot, as I mentioned, under CCMC, which is to develop a strategy for climate resilient product assessments. And I'm going to dive into those two items just a little bit deeper. So starting with the RQ'd, resilient residential retrofits. As I mentioned, so this is looking at enhancing climate resilience of existing buildings through retrofits by looking at measures for climate hazards such as flooding, wildfire smoke, extreme wind and heat, and permafrost thaw. There are technical sheets coming soon that will contain practical information for home builders and renovators and designers that will speak to resilience of hail, high wind, and wildland urban interface fires. They have also been working very, very hard on a new multi-hazard residential retrofit tool. So this is an online tool that's essentially a database that provides information on measures to address multi-hazards and how these measures relate to each other. So the hazards included are flood, extreme heat, wildfire, extreme wind, and ice and snow. Essentially, the user can select a single hazard or multi-hazards based on their area and their risk zones, and the database will generate adaptation measures. So in this case, I've got a screenshot showing some measures for extreme wind to address uplift by providing, in this case, a continuous load path at building component interfaces like roof to wall and wall to foundation connections. The idea, however, is that if you plug in multiple different hazards, like maybe overheating and wildfire, the smoke attributed to wildfire would prevent you from opening your windows, while one of the measures for overheating might be nighttime flushing using cool air from the outside. So opening your windows would be that measure. And so the database will essentially figure out what those relationships are between those hazards and develop measures that would work, assuming those multiple hazards exist. So I don't know if I can put anything in the, if I can, no, I was hoping I could drop a link in the chat. I have some slides at the end of the show, at the end of the presentation, with links to everything that I'm talking about today. So I can either dump them in the chat at the end or distribute them for folks so you can check it out. But if you wanted to plug in climate resilient retrofits.ca into your web browser, you should find this website as well. So also launched in 2023 is the CCMC, which is the Canadian Construction Materials Centre Climate Resilient Product Assessment Pilot. So we're calling this our Codes Plus project. The aim is to develop product assessment strategies that would consider criteria for construction products that go above the current code minimum. And this would be, I think someone's got themselves off mute. If you wouldn't mind muting yourself. The idea is that we would be able to provide a demonstration of resiliency to various climate hazards such as wildfire, extreme heat, and so on. The goal is to accelerate climate resiliency and adaptation for Part 9 buildings during this intervening period between now and when resiliency is integrated into the codes. So the idea is that we would create criteria that's derived from relevant published guidelines or standards, and we would use published NRC design tools, which we'll talk about a little bit later on. And if no criteria exists, then we will look to develop criteria through research with academic and expert partners. The assessments under the pilot are absolutely voluntary for manufacturers, but there is the prerequisite that they must meet code minimum for their products. So that's a high-level overview of that work. Our current focus at the CCMC is wildfire, extreme wind, extreme heat, and hail. And I'll go over in a little bit more detail what that work entails. And we do have efforts underway to launch our Codes Plus services, starting with evaluations to wildfires in early 2026. So before I move on into some more detail about the work, I just wanted to speak briefly about the upcoming codes. So, you know, just a reminder that in a lot of cases, codes are just one of the tools that we need to work with other tools such as land planning and retrofits to achieve our resiliency goals. But with that said, in the 2025 National Model Codes, there are mitigation provisions to refine energy efficiency tiers. Those were introduced in the 2020 codes. And there's a new objective to address greenhouse gas emissions and excessive operational greenhouse gas emissions in buildings. Adaptation measures include solutions for overheating in indoor environments. And there's an introduction of forward-looking climate data, so future projected climate data. And I believe that we are the first building code in the world to use future-looking climate data in their national codes. There are currently policy discussions underway that will inform the 2030 codes, and those discussions are really to determine the role of codes in mitigation against wildland-urban interface fires, permafrost, and extreme winds. Looking at the 2030, I should say that 2025 codes are due to be published early in 2026, so we should see those coming out soon. The 2030 codes, they will have provisions for mitigation that look at continued development to refine energy efficiency tiers, including greenhouse gas emissions. And there'll be a focus on operational and embodied greenhouse gas emissions, heat pumps, and energy performance. Adaptation measures will include work on overheating, continued work on overheating, I should say. And as I mentioned, there's still these policy discussions ongoing, but the potential areas for adaptation could include provisions for flood-resistant design, resistance to high wind events, permafrost durability, and wildland-urban interface fires. Now, I mentioned that this 2025 codes will have future-looking climate data. This data will be based on a 2.5 degrees Celsius global temperature increase. There is an online tool called the Design Value Explorer from the Pacific Climate Impacts Consortium. And this web tool was developed in collaboration with NRC and Environment and Climate Change Canada. It provides all of the design details for different degrees of global warming. So from 0.5 degrees Celsius up to 3.5 degrees Celsius at 0.5 degree increments. And this is to inform the design of buildings and infrastructure. So you can look up design values for heating degree days, moisture index, rainfall, 1 day rainfall, 15-minute rainfall, and annual rainfall, I believe. You can find the design temperatures for January and July, snow loads, wind pressures, driving rain and wind pressures, all based on your location and the degree of global warming that you choose. So it's an interesting tool and worth checking out. Again, I'll try and drop the links to these in the chat at the end of the presentation, but again, you could also plug Pacific Climate Impacts Consortium into your web browser and toggle around with some of those as well. So I'm going to move in now to the climate hazards that we're addressing at the National Research Council, and I've broken my deck up into climate hazard variables, so wind, wildfire, flood, and hail. In some cases, there are multiple efforts underway by the main Climate Resilient Built Environment Research Initiative, and then the CCMC work, and then the Resilient Residential Retrofit theme. So I'll go through each climate variable, and I'll speak to the work that we're doing under each of these umbrellas, starting with wind. So high-level overview, under the Climate Resilient Built Environment main umbrella, there is some research that is looking at structural design requirements for Part 9 and Part 4. The Resilient Residential Retrofit has also compiled a list of retrofit measures within their design database. That's that online tool that I spoke to earlier. And the CCMC is working to update internal technical guides and the CAN-ULC standard S742 for air barrier systems to align it with our current codes. So diving in a little, starting with the major umbrella, the Climate Resilient Built Environment, there's structural design work is looking at addressing tornado loads for new buildings and retrofitting of existing buildings, and that would be relevant to Part 4 and Part 9 of the National Building Code. So essentially, the project started up in August of 2023. The expected completion will be June 2026. This is in partnership with Western University, and the output will essentially be a guide that addresses tornado loads for new and existing buildings. There will be a series of code change requests for Part 4 and Part 9, and the final reports will come out, as I mentioned, in June of 2026. So if those code change requests are successful, we wouldn't be seeing anything in the codes until at least 2030. But hopefully that's some information upcoming. Moving into CCMC's projects, the Extreme Wind Loads project that we're working on launched in August of 2024. This is again in partnership with Western University, and Western scope is estimated to end in October of 2026, and we're hoping to finish up CCMC's scope, the Canadian Construction Materials Centre scope, in June of 2027, and that final scope would be under our Codes Plus to provide climate resilient assessments to stronger winds. So as a bit of background, the CAN-ULC S742 standard for air barrier systems was first published in 2011. That was based on CCMC criteria that was developed back in the 1990s. It contains wind pressure tables required for wind loading on full-scale wall assemblies, and the 2011 edition is referenced in the NBC 2015 and 2020. However, there were changes to the wind load requirements in 2015 and 2020. And those changes were not captured. They were changed, the changes to wind load requirements, I think I said that. Those were not captured in the current edition of the standard. So we saw a need to have a look at that and update it. It's a fairly large project, so we decided to move into a phased approach. So phase one is essentially to benchmark. So to provide recommendations for updates to align the standard with NBC 2015 and 2020. So this phase one report was completed in March of 2025. The S742 task group approved the experts' recommendations, and there is now a working group working on updating that standard. They're waiting for the phase two report, which will aim to align the standard with NBC 2025, which contains, as I mentioned, the future-looking climate data. So the current objective is to aim for a revised edition of the standard consistent with NBC 2025 to be published in the second printing of 2025. So phase two, as I alluded to, is the projected wind loads. So that's to provide recommendations for updates to align the standard with NBC 2025 future-looking climate data. So that draft report was received late last month and is currently undergoing review by CCMC and the S742 working group. Phase three of this project is extreme wind events. So this phase would look at including wind speed mapping for derechos, thunderstorm fronts, and downbursts. It will evaluate pressures from these extreme wind events, and it will include tornadoes. That portion of the work will piggyback on the tornado work that I mentioned in my earlier slide that's ongoing under CRBE. None of these wind loads are captured in the current or upcoming National Building Code. So the deliverable from this phase would be new wind load tables for extreme wind events, and these are intended to inform CCMC Codes Plus evaluations. Again, updates from each phase of this project impact several of CCMC's cladding technical guides. So those technical guides, along with some roofing technical guides, will also be updated under this research. The project, as I mentioned, is looking to complete by August of 2026, with CCMC offering evaluations by June of 2027. So resources. There is, well, here it's just, I'm just providing here a list of climate resilient wind-related events, wind-related standards, guides, and tools. So for standards, there is a CSA A123.26 which is performance requirements for climate resilience of low slope membrane roofing systems, and CSA S520, which is design and construction of low slope residential and small buildings to resist high wind. I mentioned that there's this upcoming guide for tornado loads for new buildings and existing buildings for Part 4 and Part 9. That's coming in the summer of 2026. And there's also an online tool that some of you may have heard about called Climate RCI. It's a web-based tool for roofing design, and it was developed and maintained. It was developed and is maintained by the National Research Council. It's used for determining design values for wind, rain, and temperature, and it determines the roof performance requirements based on that climate severity and climatic loads. You can use it for current and future projections for Canadian cities. I'll dive in a little bit for those who are not so familiar, but essentially, as I mentioned, this was a tool that was developed by the NRC, is maintained by the NRC. It will probably need to be updated to align with the NBC 2025 wind loading, but it's used, as I said, to determine design values for wind, rain, and temperature for roof performance. So essentially, the user can select the city, location, and global temperature that they want to evaluate. So this global temperature is the same as the temperatures that I mentioned in the Pacific Climate Impacts Consortia tool. So you can select global temperature increases from 0.5 degrees Celsius to 3.5 at 5-degree increments. And essentially, the tool will generate a climate determination based on your province, your city, and the global temperature that you selected. And it will define climate categories normal, severe, and extreme for wind, rain, and temperature. So just diving in a little bit, here's essentially your outputs. So for the design parameters for wind would include outputs for hourly wind pressure, 1 in 50, to be used to calculate wind loads following NBC subsection 4.1.7 wind loads. And your rain output would include the 1 in 50 one-day rain, which would be used for calculating rain loads following the procedure outlined in section 4.1.6 of the National Building Code. And for design temperatures, the outputs will include a maximum daily temperature and then your design temperatures for July and January. I've selected Ottawa here because I'm in Ottawa, and I've used the 2.5 degree global temperature rise. And I was, I guess it's been a while since I played around with these, but I was surprised to see that the January design temperature, 2.5%, is -15, and the 1% is -17, because I think, going on memory, currently it's -25. So that's a significant design temperature warming value. So it's just an interesting tool to play around with and have a look at the direction that things are going. Onwards, however, once you've input all of that data, the tool will output the climate determination. So from here, you can define the parameters for the building geometry. So height, width, length, parapet height, if there is one. You can define your building exposures. So open terrain or rough terrain. Rough terrain would be suburban, urban, and wooded. You can define your building openings. So there are 3 categories, ranging from no significant openings to larger openings that can be closed but would involve a lot of air leakage, to significant openings that can't be closed. Additionally, you can input your importance category here. So your low importance would be your low human occupancy buildings, like storage warehouses, barns, so on. Your normal importance, which would be the majority of buildings, including residential, and your high importance, which would include post-disaster shelters like schools and hospitals. Once you've input all of those details, the tool will generate factored wind loads for the roof and the parapet, and you can then continue on to select your performance requirements. And here you can see it's essentially a summary of the performance requirements based on the resiliency index that you chose, the global temperature, the roofing system type, sloped versus steep, the climate category, and the performance requirements, and so on. So note that this summary directs the user to the CSA A123.26 standard, which is the climate resilient standard for low slope roofs that I mentioned in my earlier slide. And again, you can toggle the tabs here for design summaries for wind and temperature as well. I think I've just got the, I've just got the wind summary up here. So it's an excellent tool for those who are designing roofs. I know it's very roof centric, but it's an excellent tool that does look at future looking climate data and future looking wind pressures. So that's what I have for wind. I'm going to move on to wildfire now. I feel like I talk about wildfire all the time, and I may have already mentioned wildfire a lot in this presentation so far, but you know, just to recap, the Climate Resilient Built Environment published the National Guide for Wildland-Urban Interface Fires under their first Climate Resilient Initiative, which ran from 2016 to 2021. So this publication came out in 2021. Now, there's a new initiative right now under our current funding to support the ULC in the development of 2 national standards on WUI fire resilience. So these standards will be based on the Guide for WUI fires, and they're targeting publication for these 2 new standards in spring of 2028. Additionally, under wildfire, with our current funding, there is new research underway that will be looking at wildfire smoke. So research on wildfire smoke impacts through lab tests, field monitoring, and airborne data collection to guide mitigation strategies and potential NBC updates. This work it's a work in progress, and it's expected to complete somewhere between 2026 and 2028. And then I just wanted to kind of look at a timeline of the evolution of the WUI Fires Guide. So, and to bring you up to where we are today. So as I mentioned, the guide was published under the first initiative in 2021. It is publicly available on our website, and it will serve as the seed document for these 2 new standards. The publication, as I mentioned, is aimed for 2028, but and I also mentioned that there are some discussions underway to determine the role of codes with respect to wildfire resilience. So at this time, we don't know what codes will do with this. But in this intervening period before standardization, CCMC has developed evaluation criteria for roofs, cladding, and decking based on the requirements of the WUI Guide, Wildland Urban Interface Guide, for the purposes of evaluating them under our Codes Plus pilot. So there are, as I mentioned, efforts underway to get this pilot launched in early 2026. The WUI Fires Guide will be the first of the climate hazards that we will offer for this new service line. And we're hoping, as I said, to be able to offer these in 2026. And I think I also mentioned that any product that's evaluated under Codes Plus must first meet code minimum before we can evaluate to resiliency. But the idea is that evaluation to the WUI guides will provide some standardized demonstration of resilience that can be used by designers, planners, and communities in their decision-making processes if they're building or rebuilding in wildfire-prone zones. Now, once standardized, the CCMC will look at shifting its evaluations to ensure that it's aligned with the standard. And then, the next step from there would be a code change request. So if there's a successful code change request and the standard is codified, then the idea is that the criteria becomes code minimum and CCMC removes it from our Codes Plus evaluation service, and it just goes into the regular code minimum stream. So that's the work on wildfire and the vision down the road for wildfire. Moving into flooding, the NRC has extensive research facilities under the Ocean, Coastal, and River Engineering Research Center. So these facilities include wave basins and modeling. So we're modeling the performance of dams under climate change and the impact of nature-based solutions and how we can use them to help mitigate coastal erosion and coastal flooding. We also have a stormwater simulator to measure the ability of roofing assemblies, such as green roofs, to retain water and help mitigate urban flooding. And we have a new flood barrier testing facility, which is helping to advance whole building flood resilience. So it includes roof water retention solutions and flood protection measures. It essentially has the capability of simulating a full-scale building in flood situation. So it will be instrumental in helping to advance construction methods and validating flood protection systems. Because the mitigation and adaptation for flooding is more related to building design, site design, community design, the CCMC doesn't have any work in terms of the Codes Plus under flooding, but I can direct you to some of the research and the publications that have already been out. So again, all of these publications are available on NRC's website. For infrastructure, maybe this isn't the crowd for infrastructure, but there is a guide for coastal flood risk assessment guidelines for building and infrastructure to support flooding resilience on Canada's coasts. And there is practical guidance for private side drainage systems to reduce basement flood risk. Specific to buildings, there are guidelines for improving flood resistance for existing buildings and flood resistance for new buildings. And I think I mentioned very briefly earlier on that there is a third publication underway that will provide a guide for flood loads and flood combinations. And the intent is that these three documents will help to inform model codes moving into 2030, addressing mitigation and adaptation for flooding. So moving into hail, we maybe don't see the type of hail that folks out in Alberta see, but hailstorms do pose a significant threat to building integrity. They cause considerable damage to roof coverings and cladding. And as climate patterns evolve, we're seeing the frequency and severity of hail events increasing. So this is really I'm going to just trip over my words here. This is necessitating the development of some more robust evaluation standards, specifically in areas that are very hail prone, to help in the selection and installation of hail resilient materials. So currently there are some existing standards for roofing, though there are some shortcomings that have been identified in the test methods where the impact resistance doesn't really the impact resistance test methods don't really mimic the impact that is seen from hailstones. So in the spring of this year, well, and I should also say that there are no existing standards for cladding. You can see in this picture here that, that cladding took a real beating. So, in the spring of this year, CCMC began to discuss how we could address hail impact resistance for roofing and cladding under our Codes Plus pilot. This was following the Calgary hailstorm in 2024 that caused $2.8 billion of insured damages. Now that was 2 times the insured losses associated with the very memorable June 2020 hailstorm that happened at the edge of Calgary, where I think 77,000 homes were damaged, and I think the cost was around $1.4 billion in insured losses. So hail damage is significant. And coincidentally, or maybe not, shortly after we began those discussions, CCMC was contacted by the Institute for Catastrophic Loss Reduction, and we had a meeting with the Institute for Catastrophic Loss Reduction, also known as the ICLR, and the Insurance Bureau of Canada and the Standards Council of Canada. the Insurance Bureau essentially suggested that the insurance industry in Alberta is in crisis due to hail. Those conversations led to opening up the conversation with Western University as well. They have a Northern Hail Project group that aims to essentially collect data and improve knowledge on the damage of hailstorms. We don't have a huge amount of data on hailstorms and hailstorm damage, but that work is underway and ongoing. So in short, maybe I'll jump to the next slide. We're working with, so starting in March of 2026, we officially started up a project and efforts to work with the NRC Research Group and Western University in collaboration with the Insurance Bureau of Canada and the Institute for Catastrophic Loss Reduction. And we're looking to develop cladding criteria for hail-resistant exterior wall claddings and update roofing standards where needed. So the NRC cladding group is working closely with us on the cladding portion. The roofing group has already started this work, and we're supporting that as we go. And in the end, both scopes are intended to complete somewhere in March of 2028. So by then, we're hoping to be able to provide Codes Plus evaluations for hail resilience. There is, as I mentioned, we're working with the Standards Council of Canada as well. So the hope is that down the line, once we have evaluation criteria developed, we can move to developing a national standard if the demand is still there, which I suspect it will be based on where things are at. As far as hail resources go, this is a less published area. There are a handful of impact resistance standards, as I mentioned, that are out there for roofing. These do have the shortcomings when it comes to assessing hail impact resistance. But I will say that the Institute for Catastrophic Loss Reduction, the ICLR, has some resources on their main website and on their Hail Smart website. I've got links here. You can't link them from your screen through the presentation, but again, I'll provide some links towards the end of this presentation, and maybe we can distribute them afterwards. But again, there's very little data at this point on hail resilient cladding or hail resistance cladding. So that work is upcoming. So in other work, the CCMC is poised to support other CRBE work, climate resilient built environment work, including the development of a national text specification for exterior solar shading, and that would be to help mitigate overheating of interior spaces. We have a couple of projects aiming to start up as well in April of 2026. One would be extreme heat, and this would be to identify building envelope components susceptible to premature failure associated with the with the extreme heat and intensified UV that we're projecting from future climate data. That work is targeted for March of 2028 as well. And to support the Codes Plus pilot and a lot of the work that CCMC is doing under the climate resilient built environment, we're targeting a marketing and education blitz for 2026 and 2027, where we will focus on education and support for designers, building officers, building officials, and create some awareness of the Codes Plus services for manufacturers as well. I have come to the end of the list of everything that we are doing related to Part 9 buildings, and I know I've just thrown a lot of information at you with respect to codes, tools, work underway for wind, wildfire, flood, heat. I've mentioned some tools and resources, and I'll close by saying that as we come to the end of our phase 2 of the climate resilient work, we're working actively with HICC, Housing Infrastructure Communities Canada to start phase 3 of this research beginning in April of 2026. And that will really continue to expand on everything that I've talked about today and to continue to update standards for resiliency. It's a work in progress, and we can plan to meet every 6 months, and I can update you on where we're at and where things are. Essentially, I've just got a couple of slides here with our tools and links. So again, for roofing design, we've got climate RCI, for climate resilient retrofits, for single and multi-hazards. We've got the climate resilient retrofit website. And again, if you want to look at different design values for various degrees of global warming, you can check out the Design Value Explorer. And I've included also a list here of all of the publications that I mentioned. And maybe after this, I can connect with John and Tanya to make sure that I at least get these last 2 slides to folks so that you have access to all of these links and tools. And with that, I will thank you very much for your time today. Sorry for the bumpy start. I'm happy to answer any questions that you may have. So I'll maybe turn it over to Tanya.
Okay, perfect. So I'll include, if you don't mind, I can include the last pages to the email I'm going to send out the recording of this session.
Great.
So I can, if you could forward that to me.
I'll forward those to you. Yep.
Perfect. So if anybody has any questions.
Blanche, did you have your hand up?
Yeah, I was looking.
Well, I guess I covered it all. I
Yeah.
like to wait the extra minute for all the introverts, because that's my category. There we go.
Oh, so I'm just, wait one moment. Blanche has a question. Oh, thanks.
No, well, you're welcome. You're welcome.
Okay. Well, great presentation.
Anything in the chat there? Yeah. Okay.
Perfect. Okay.
Well, you know how to find me. That's my email on the screen there. So if you have any questions later, feel free to reach out anytime.
Perfect. Thank you, Janet.
Okay.
Thank you, everyone, for your patience as well.